Applications of quadratics. In this lesson, we are going to take a look at how we can apply what we know about quadratics to some real-life scenarios. So example number 1, a stuntman is shot out of a cannon. His height, y, above the ground in meters after x seconds is given by the formula y equals negative 5x squared plus 8x plus 2. The graph of this relation is displayed below. So a few things to note. So our x-axis is here, our y-axis is there. We know that it opens down because it's negative. So that's why we have a parabola that makes sort of like an N shape. And we know that our y-intercept is 2 because that's our last constant value in our equation. So we can see that on our graph as well. So we want to know, why does this graph just have one x-intercept? So I know that we're only being shown a portion of the Cartesian plane, but why would it make sense to only just have one x-intercept right here? So this is the x-intercept right there. Well, we know that there's only one x-intercept because our x is time. So this is time in seconds. And we know that we can't go backwards in time. That's not an option. We haven't created our space-time machine, right? So we can't go back in time. It's not Back to the Future. So what we have is we just have one x-intercept, and this is the x-intercept. This is when the rocket or the stuntman reaches the ground, okay? So it has just one x-intercept because, first of all, we're dealing with time. And we can't go back in time. So we can't have negative seconds. We also know that there's only one x-intercept because that's when the stuntman hits the ground. The next question says, when or what is the value of the y-intercept? Well, we know that the y-intercept can be found from the equation of our parabola, or it can be found from our graph. So right here is our y-intercept. Remember, our y value is showing us the height in meters. So this 2 refers to 2 meters. So the y-intercept is 2 meters. And what does this tell us about the situation? So this is the initial height of the stuntman. So this might be the height of the cannon at which he's being shot out of. There might be some sort of platform that they're on. Regardless of what the situation might be, this is the original height of the stuntman. So this is how far up off the ground he is before he gets shot out of the cannon and then reaches the ground later on. This third part says, for how long was the stuntman in the air? So when does he reach the ground? Well, he reaches the ground about right here. So this x is, this measurement right here is ground level, right? So at 0, this is ground level. So this is when he reaches the ground. So he reaches the ground just after 1.8 seconds. So how long was he in the air for? Just over 1.8 seconds. Not quite 1.9 seconds, but just a little bit above 1.8 seconds. Because when he reaches the ground, that's when he's no longer in the air. And then the last thing we want to know is, or not the last thing, but one of the last things we want to know is when his maximum height is. So whenever you're looking for the maximum height, you're looking for the vertex. So we're looking, remember the vertex is a coordinate, and this y value tells us either the maximum or the minimum height. In our case, it's a maximum. So let's take a look at our graph. And we're going to try to figure out where that vertex might be. So it looks like the middle of my parabola is about right here. Right? So here's my vertex. And this, if we continue over, it's about 5 meters, right? So he reaches a height of about 5 meters. So his maximum height is about 5 meters. You could probably give or take a little bit, right? Because we were estimating from our graph. The other one wants to know for how long was he above 3 meters? So we're going to take a look at our graph again, and we're going to find out where 3 meters is. So here's 3 meters. So I'm just going to continue this line all the way across. We'll notice that it hits 2 spots on our graph, right? It's here and it's here. So what is the distance between here and here? So what is that time? So if we come down on our first point, we get approximately just like maybe 0.15 seconds. And if we take a look at this next one, we get about 1.4 seconds. So what is the difference between these? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1 second, 1.1, 1.2, 1.3. So he is above, or the stuntman is above 3 seconds for about 3 meters for about 1.3 seconds. Right, so we just took a look at what is the distance between these, right? And so the distance between here and here was about 1.3 seconds. So that's where we can take information from our graph and answer some application type questions. Let's do another example, because I think it's helpful to do more than one. So here in this graph, example number 2 says the graph shows the path that a rugby ball followed after it was kicked. The x-axis, or so the y-axis, so the right here, represents the height, so y or h, regardless, you can use either or. So this is the height of the ball, and it's given to us in meters, so that's the unit. Well, the x-axis, or d, refers to the horizontal position of the ball, so the distance of the ball, the horizontal distance, also in meters. So this is the distance of the ball in meters. So that's information from our graph. So that's just what our question says. So the graph, and this is the path of the rugby ball. So the path shows the rugby ball followed after it was kicked. The y-axis represents the height of the ball in meters, and the x-axis represents the horizontal distance in meters. So what was the maximum height reached by the ball? So the maximum height is our vertex, right? That's what we're looking for. Our vertex looks to be about right there. And so what is the height of that ball? Looks to be about 10 meters. So the maximum height reached by the ball is 10 meters. What is the horizontal distance the ball reached its maximum height? So that is this measurement right here. And that's 20 meters. So when we're looking, again, anytime we see maximum or minimum, we want to think vertex. So the maximum height is the y value, because that's the height is represented by the y, and the horizontal distance is our x. That's represented by that axis right there. The next question says, how far did the ball travel before it hit the ground? Well, we know that it started at the ground, so this 0, when the height is 0, that's when it's hit the ground. So it started at the ground, and then it reached the ground right here. And how far did it travel? It traveled 40 meters before it hit the ground again. So it started at the ground, and then it made it back at the ground at about 40 meters. So the next question says, if the kicker was 32 meters out from the crossbar of a goalpost, would the ball pass over or under the crossbar if it stands 3 meters off of the ground? So we want to think about, when is it going to be 32 meters? So when is its horizontal distance going to be 32 meters? So let's figure out where 32 is. So this is 30, this is 35. Halfway between that is 32 and a half. So it's probably about right here, right? So this is maybe 32. So we want to figure out what is the vertical height of the ball at this point. So let's go up to our graph. So we're going to hit that parabola, and we're going to go over to our vertical height axis and see where that is. Well, that's just over 5, so let's say maybe that's about 6 meters, give or take a little bit. So at 32 meters, the ball is going to be about 62 or 6 meters high. So is that going to cross or go under that crossbar? Over or under? The crossbar stands 3 meters off the ground, and 6 meters is larger than 3 meters, so the ball will pass over. So a lot of our application questions involve interpreting the graph. So trying to think about, what do we know about that diagram? And the last question says, what is the farthest distance the ball can be kicked and still pass over the 3 meter crossbar? So how far away does he have to be? So this is where we need to think about, well, where is 3 meters? So 3 meters high, this is 5 and this is 0. So this line right here is 2.5. So 3 is probably about right here. So that's 3 meters. So how far can he be before the ball is not going to make it over that crossbar? And here's 3 meters. So it's about right there. And I want to think about, okay, where is it going to be? So this is 35, this is 40, this is about 37 and a half. Maybe this is about 36 meters. So this is approximately 36 meters. So he can be 36 meters from the crossbar, and it'll still be, it'll still cross over. So he can be 36 meters from the crossbar, and the ball should still go over there. Anything more than that, then it's not going to make it over, and anything less than that, it'll definitely make it over. So that's how we can take a look at our graphs of our quadratic relations and just interpret some of that information. So we're looking at the graph and we're trying to think about what are the pieces of the parabola that we know, what are some of the definitions, what are some of the features, and how can I use those features to answer some application-based questions. If you have any questions about this, please let me know. Send me an email or a message on Teams, and I will see you in the next lesson.